Okay, let's go over the chapter 5 test. This is Form A. This is one we took in class today, or Thursday. So it says, write the equation of a circle. So I need to do x squared plus y squared equals r squared, but it's moved. So it's going to be x. If I want to move it minus 1, I go x plus 1. To move it to left 1. And to move it up 3, I got to go y minus 3 equals r squared. Now I got to figure out r. So if I do a quick sketch, the center's at minus 1 up 3. And it's got to go through 1, 2, 3. 3, 0. So the radius is from here to here. The way you find distance between 2 points is change in x, which is about 4, and change in y, which is 3. So I got 3 squared plus 4 squared equals c squared. A squared plus b squared equals c squared. 9 plus 25 equals c squared. 9 plus 16, which is 25. So if I take the square root, I get plus or minus 5, but we'll go with 5 as c, which is going to be the radius. So the radius is equal to 5. And the radius squared goes here, so 25. So there's the equation of the circle. And the length of the radius is 5. Now, some of you, when doing this problem, did it this way. He said, okay, if it's got to go through 3, 0, we put 3 in there, and we get 3 plus 1 squared plus 0 minus 3 squared is r squared. So that's 4 squared, or 16, and minus 3 squared, which is 9. So r squared is 25, and r is 5. It's another way to get it. Some of you did it that way, so I said I'll show you that. Unit circle. Well, the unit circle has the equation x squared plus y squared equals 1, because on the unit circle, any point on the circle is over x up y, and the radius is 1. X squared plus y squared equals 1. A squared, that's Pythagorean theorem. So the x is 0.235 plus y squared equals 1. 1 squared, but that's 1. So I'm going to square that and take it away from 1. So I'm going to write let's get it up here where you can see it. I'm going to type in 1 minus 0.235 squared, and that's what y squared is. 0.9447775. That's what the calculator is given for that. And then I need to take the square root. Square root is the 0.5 power. And so that's 0.97199. 0.9777199. So let's just make it rounded off to 2. That's approximately it. But there's 2 places where x is 0.235, one up there and one down there. So it's plus or minus. Those are the 2 y coordinates. Plus or minus. Okay, if you ever got radians and it has a pi, that's an easy convert, because pi is the same as 180 degrees. Or 4 pi over 7 radians, and we want the radians to cancel. We multiply by 1, We want the radians to cancel, so I'm going to put radians and degrees, and pi radians is 180 degrees, so this is 1. 1 times this doesn't change its size, but it does change how it looks. The pi radians cancels the pi radians, so I got to take 4 times 180 divided by 7. Same thing I would get if I just replaced the pi with 180. And that turns out to be 102.8571429, blah, 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 blah. Okay, and then to change that degrees, minutes, seconds, well, this is degrees. We got 102 degrees, so we're going to write 102 degrees. Take that off because we got that, so minus 102. This is a fraction of degree, so it's 0.85 hundredths, but we want it in 60ths if we're going to do minutes. So I'm going to take it times 60 to say how many 60ths, oops, I did divide, times 60. That turns out to be 51.42 something minutes, but I don't want the decimal, I want it in seconds, and since that's already been multiplied by 60 once to get the seconds, I get rid of the 51 and take that times another 60, so I'm really taking it times 3600, and I get 25.7-ish seconds. All right. So now I want to change this back to decimal format. So that's 35 degrees plus 57/60ths of a degree plus 9/3600ths of a degree, because there's 3,600 seconds in a degree or hour. And I get 35.9525. Now to convert degrees in decimal to radians, I got to multiply by, I want the degrees to cancel, so I'm going to put 180 degrees in the denominator, so the degrees are going to cancel. And 180 degrees is pi radians, and if I want decimal, I'm going to use the decimal value of pi. So I'm going to take my last answer times pi divided by 180. And I get, in radians, 0.6275 is good enough. Okay. Now, I should have said give the exact value with no trig functions left, because that's what I meant for you to do. I don't mean for you to try to do anything with the square root of 2 per se, but the cosine of 30. So if I go to the unit circle, I know that 30 is only a third of the way up to there. So that means this side's long and that's short. And in that case, the cosine being this one, that's the long side of a 30, 60, 90, which is the square root of 3 over 2, if the hypotenuse is 1. Minus 4. Now the sine of 3 pi over 4, 1/4, 2/4, 3/4 of the way around to pi. So that would be here where they're both the same length, except this one's minus. Minus square root of 2 over 2, and this is plus square root of 2 over 2. And we're doing the sine, which is the y coordinate, so it's times square root of 2 over 2. This reduces. This doesn't cancel because that's inside, that's outside, but we can multiply that. So we get square root of 6 over 2 minus 2 goes into 4 and leaves 2 square roots of 2. That's what I kind of expected most people to do. Okay, page 2. So, the Pythagorean theorem for trig is sine squared of an angle plus cosine squared of the same angle is 1. So if the sine is negative 5/9, we have negative 5/9 squared plus cosine squared is 1 squared, or 1. So I got to figure out what 1 minus parentheses negative 5 divided by 9 squared is, and that turns out to be 0.691-ish. And then I take the square root, which is the half power, and so I get the cosine of phi is either a square root, you get plus or minus 0.8 315. Okay, so that's the cosine. Oh, I said exact values, so I can't do what I just did. So I've got to go cosine squared phi is 1 minus 25/81. 25 divided by 81. So then I think of 1 as 81 over 81 minus 25 over 81, which is 56 over 81. So the exact value of the cosine of phi, take the square root of both sides, is the square root of 56 over the square root of 81, plus or minus. Now we have to decide which one to use. And the tangent's positive, and the tangent is sine of the angle over the cosine of the angle. And if the sine is negative and the tangent is positive, the cosine must be negative, so we're going to use square root of 56 over 9 negative for the cosine. And the cotangent is not, the tangent is sine over cosine, so the cotangent's cosine over the sine, which makes the cotangent positive, and that's, the minuses cancel, the 9s will cancel if I multiply by 9 and 9. Actually multiply by 9, it's 9, and minus 9, that gets rid of the minus and the 9, and I get square root of 56 over 5. And if you wanted to, you could reduce the square root of 56, because that's 4 times 14, which is 2 square root of 14. So I could have used 2 square root of 14 there, or there, and there. Cosecant has a co, its reciprocal is sine, so it's the reciprocal of that, which is negative 9/5. Okay. Now I give it, one angle is in degrees and one's in radians, and you got your choice for what you want to do to find y. Now you could think of 90 as pi over 2, So that means these two have to be pi over 2. So if we take pi over 2 minus 2 pi over 5, common denominator would be 10. So this is 5 pi over 10 minus 4 pi over 10, which is simply pi over 10. Or you can convert this. So 2 pi is 180 degrees divided by 5, and 5 goes into 180. 36 times 2 is 72 degrees is the degrees for that. Take that from 180 and you get 18 degrees, which is 180 divided by 10 is 18. So y is either 18 degrees or pi radians divided by 10. Now, the only side we know is this one. So if I stick with this angle, 18 degrees or 2 pi over 5 radians, it's adjacent. And if I want to find x, that's the opposite. So tangent of an angle, and our angle is 2 pi over 5 or 18 degrees, has to equal opposite over adjacent. So if I multiply both sides by 25, I get, and since my calculator's already in degrees, I'm just going to use the degrees. Tangent of 18 times 25, and I get 8.2123 for the length of x. And for the length of y of z, that's the hypotenuse. And to avoid errors, I'm going to use the 25. I'll stick with this 18-degree angle. So that's adjacent and hypotenuse. And the cosine of not 18. Ooh, did I use 18? Y is 18. This is 72. Go back up here. Oop, 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 oop. I should have used 72 in here. Boy, don't want to make a mistake on this. So it's not 8, it's 76.9. 94. That's what x is. That's better. It should be bigger than 25. And down here, the cosine of 72 degrees, or this angle y, x, the cosine is adjacent over the hypotenuse, which in this case is z. So to solve for z, I'll multiply both sides by z so that the z's cancel out here. And this is a number that I have to divide both sides by. To get rid of it on this side, so z is 25 divided by the cosine of 72. Which is 80.90 for z, longer than either of these two. Okay, page 3. if the arrow stops here, that's where that stops. A lot of people were asking me that during the test. I don't know why. If the arrow went to here, it'd be 280, but it stopped there. So that's 280. 22, and this is next to the 22 is 280, and that's the hypotenuse because it's across from the 90, so I need to do adjacent and hypotenuse. So that's cosine of 22 degrees is the adjacent divided by the hypotenuse, which is y. So I'm finding y. To get y out of the denominator, I have to multiply by y and divide by the cosine of 22. So y is going to be 280 divided by the cosine of 22. And that is 301.98, basically 302. Now, this is a right triangle. So if that's 90, these two have to be 90. So for a z, I'm going to take 90 minus 22, which is 68. And for x, I'm going to look at the big triangle, and since this is 22 and 68, this has to be 90 because those two add up to be 90. So I can say x is the adjacent to the 68. So cosine of 68 is adjacent over, that doesn't include this, so I can't use this. So I'm going to have to use my y, which was 302. No. Adjacent to hypotenuse. I can't use that one. I have to use this one because that's what's in this triangle, and that's opposite of this because this is the hypotenuse of the big triangle. X is the adjacent. So I got to use tangent of 68 is opposite over adjacent. Or I could use the 22 and call x the opposite. Tangent of 22 is x over adjacent, where this is the hypotenuse. And that's y, which is 302. So here I'd multiply by x and divide by tangent of 68. So there's my last answer, the 301. And if I divide that by tangent 68, I get 122. I could also take that answer and multiply it by tangent 22. Tangent of 22 times my last answer, the 301.98, and I get 122. Okay, back page. Okay, these things, there's several ways to go. This one, not very many, but cosecant it's got a co, so it's 1 over the non-co, the sine of the angle, and it's important. Sine by itself, it means nothing. It has to be of an angle. Over cotangent. Now, if you know cotangent is cosine phi over sine phi, you'll get to the answer more quickly. If you don't, you can call it 1 over sine for the cosecant. And cotangent is 1 over the tangent. Now you can take this and multiply by tangent phi and tangent phi. That would get rid of these, and we get 1 over sine of phi. Tangent is sine over cosine. And the sines cancel, and I get 1 over cosine phi, which is secant phi. If I do here, I can multiply by the numerator by sine of phi and sine of phi, and this becomes 1 over, these cancel, over cosine phi, which is secant phi. Okay. I could distribute this times the 1 and times that, but 1 minus sine squared, since sine squared of an angle plus cosine squared of an angle equals 1, 1 minus sine squared is cosine squared of the angle, times tangent, which is sine of the angle over the cosine of the angle. Notice I'm putting angles every time. And secant is 1 over the cosine of the angle. It's a reciprocal cosine. These are all multiplied, so you multiply straight across, and if you're canceling, cosine squared is cosine times cosine, and that would cancel a couple of cosines in the denominator, and I'm left with sine times 1, or sine, over 1 times 1 times 1, which is just 1. And finally, a couple ways to go here. We can say secant squared minus 1 is tangent squared. So we can have cosine squared of phi times tangent squared of phi. And tangent is sine over cosine, so this could be cosine squared phi times sine squared phi over cosine squared phi. And the cosine squareds cancel, and we get sine squared of phi. You could also say, say this is cosine squared phi times 1 over cosine squared phi, because secant is 1 over the cosine. And you could distribute this, so cosine squared of phi times 1 over cosine squared of phi is 1. And that times that is minus cosine squared phi. And 1 minus cosine squared is sine squared phi, because 1 minus cosine squared is sine squared.